Welcome to Reality Creative Video. I'm Hermes. Today we're going to talk about the multimeter. I've gotten some comments over the last few months, maybe one just today, on how to use the multimeter. You know, I was thinking about it. I said, well, maybe I can make a short out of it or something quick. And then I realized, you know, there's a lot of things I assume about the multimeter because I'm very familiar with it over the years, and people who are actually new to the multimeter may not actually have that knowledge. And so now I'm thinking, well, how do I break a show down to, in under 10 minutes on how to use a multimeter with your Alchemy? Well, I've already eaten up about 2 minutes or a minute and a half of the show already, just blabbing about this. So let's get into it. With low voltage electrolysis, you need certain things to make that work. A power supply could be one of these power bricks, could be my handy battery pack that you make with 3 9-volt batteries, or it could be the side of the camera now, the big 60-volt power supply over there. So you need a power supply, which then gets hooked up to the rods. This is a silver rod, which will get the positive of the power supply. That's the red lead, is the positive of the power supply. And the negative of the power supply is going to be the anode. And in the case of most of the metals, copper, zinc, silver, we're going to use a carbon rod. And that gets the negative of the power supply, which is the black lead. Now, the other thing that goes along with power supply is a current meter. And the reason we want to use a current meter is because you got to add chemicals, household chemicals, to the low voltage electrolysis process to help it along. Like in the case of zinc, without any chemicals in there, it'll take over 6 hours to cook zinc. And it won't come very well either. And it won't be very stable afterwards. It might only last a couple weeks before it starts falling apart, maybe even days. Sodium citrate and citric acid are the 2 chemicals that I use, basically. There are a few others in there too, but for most of them, that's the 2. But to get it done right, you have to have the right amount of the stuff in. You don't want too much in, because we want to reduce the amount of household chemicals that are in there in the first place. The colloidals are supposed to be natural and free and, as clean as possible. And we don't, want too little, because then that's not going to be enough to stabilize the colloidal. So we need to have just the right amount of the stuff in there. Now, the only way to know that, because mixtures vary, the water varies, and how much water you're using varies. The only way to know that is with current flow. At least it's one of the main ways. So what we do is we add some drops of the solution or the powder, whatever you're going to use, and we watch the current meter and see it go up. And we set it to a certain amount. I think offhand is about 2 milliamps. Now, if you don't put any sodium citrate, it starts out at 240 microamps, or 0.24 milliamps. Now, if you're using this or this, there's no meter involved. There's no meter here. You have to add a meter. My big power supply, 60-volt power supply, has a meter in it, but it's not accurate below 5 milliamps. Anything from 5 milliamps to 5,000 milliamps, the big power supply works fine. But if it's under 5 milliamps, it's not accurate at all. And so that's why we need the multimeter. Now, not all multimeters are created equal. Some only do voltage. We want one that does voltage and current. And this one's a simpler one. They don't make it anymore, but anyway, you'll see it has AC. This is for diodes, don't worry about that. This is resistance, DC volts, AC volts, DC amps and AC amps, milliamps. Okay, so you select what you want. In our case, we're going to use the DC, because we're using direct current, milliamp, setting. And whatever meter you use, it will have something in there. This one's a little bit more complicated, has a lot more settings, but you want to set it somewhere around under the 200 milliamp scale. Okay, so you can see the current that you're going to be using for things like zinc. If you click in gold or platinum, you cannot use these meters. You'll blow them up. So no point. You can use them as long as you use them on the 10 ampere scale. That's if this meter has a 10 ampere scale. It's usually a separate switch. This has 20 milliamps, 200 milliamps, and 10 amps. Now, if you're going to cook gold, which is going to be like 300 milliamps, and platinum, which is over 1,000, you're going to need to use the 10 amp scale. And some meters have a separate 10 amp plug you got to use when you use that scale. That's if you don't have a current meter on your power supply. This meter here, it just does milliamps. It doesn't do 10 amps. So now, most meters come with leads. They usually look like this. Unfortunately, this does not help us with hooking up wires and stuff. We need clips. Now, you can get leads online that have alligators at the end and plugs that you can plug into your meters to convert this to this. Or you can use these things and clip them. You can buy a bag of these things, 15 or 20. You can use these things and hook the things up. Depends on how much you want to get involved in it. If we're using a battery pack, we definitely need something like this. Gotta go, put the red lead on the positive. If you're not sure what the positive and the negative is, that's what the multimeter can be used for. You can use it to measure the power coming from whatever power supply you're using. Like if you're using this, you don't know what the positive and the negative is. So you'd have to plug this in, and then you throw your leads on here. Red is positive, black is negative, and then the meter will then tell you which is the positive and which is the negative wire on this thing, which you'll need to know actually if you're going to hook this up properly. We need to trickle the current to anywhere between 5 to 20 milliamps. And so we're going to have to put the meter in series with this. So let's just say I have clips. Okay, we're going to use this meter, and we're going to plug the black into the common and then the red into the volt milliamp thing. This has to be in series with the power supply. So let's say we're using my battery power supply, because I have it correctly identified as minus and plus. So you're going to take the positive. Now, it doesn't actually matter which lead you use and which direction you hook this up to. The only thing that's going to make a difference is you might get a negative current reading instead of a positive current reading. We're just interested in the current reading. It doesn't matter if it's negative or positive. But if you want a positive current reading, you're going to hook the positive of the battery to the negative of the current meter. And now you're going to have a red and black. This becomes the negative, which connects to the anode of our setup. And this becomes the cathode, which connects to the silver. We're cooking silver, copper, to the cathode. And then we turn the meter on, and it will tell us the current flow. Now, there's zero current flow because there's no water in here or anything like that. But if I had water in here and had the stirrer going, and I started to either sprinkle the sodium citrate in or drip it in, I recommend using the stock solutions. Drip the sodium citrate in there, you will start to see the current flow go up. And you set it to whatever it is that I have in the video telling you what it is. But that's basically how you hook up the multimeter. And that's it. Then you cook your colloidals for however long you're supposed to cook them for. It's really the starting current that's most important. The finishing current isn't important. You can watch the current meter. Interesting thing about the current meter is it will show you as the current starts to go up for most colloidals. That means the colloidals are going in the solution. The colloidals are metal. So the more metal that goes floating around in the solution, the lower the resistance is, and so the current will increase. So it's a good indication you're getting colloidals in there when you got the current slowly increasing. So I know this was supposed to be just on the multimeter. I hope I covered enough of the multimeter that you understand now how to hook it up and how it needs to be in series with the power supply so that you can get a reading. If you're getting no current on the meter, it either means you don't have it hooked up properly or you have no power on. So just have a look and see at your wiring and take it from there. And I will talk to you again soon.